In this session, I'll be covering, at a top level around what the typical, Kubernetes deployment would be and how UIM is going to jump in with respect to monitoring the Kubernetes cluster and the cluster components with respect to nodes and pods. So typical Kubernetes cluster deployment will generally contain, a master node, and generally it is recommended to have a high availability configuration. So there will be, more than, one master nodes for HA support, and then the actual job will be done by the worker nodes, and then there will be a network for communication. Now, from a master node perspective, there are some of the key entities that uh, will be installed on the master node, which is the control plane for the overall Kubernetes cluster. One is the first one is the API server, which is the key component uh, within the master node for providing the command line interface or for the APIs or for the client access, browser access itself, right? And then we have the schedulers for scheduling the pods on the nodes, and then the controller responsible for the life cycle, and then the etcd key store, right? So these are some of the critical components on the master nodes. And then on the worker nodes, we generally have a kube proxy, and then kubelet, followed with a set of pods, which are nothing but kind of wrappers on top of the underlying containers, right? So this is how a typical production scale deployment would be in a Kubernetes cluster. Now, how UIM is going to monitor these kind of Kubernetes clusters, right? And by the way, UIM supports multiple HA configuration or a single master node or a single node deployment. Uh, and The way UIM monitors this entire Kubernetes cluster is nowhere different from other containers when it comes to the deployment aspect. As you can see in this slide, so as part of monitoring a Kubernetes cluster, there will be a deployment file that will be available. Uh, I'll be showing this deployment file in detail. Basically, this is all about deploying two containers or associated pods on the Kubernetes cluster. One is the cluster info, and second one is the Kubernetes monitoring, right? So cluster info is a container image that will be available in the standard repositories like JFrog Artifactory or the Docker Hub. And the other one is Kubernetes monitoring, is nothing but the UIM robot itself. So the first one is the one which actually exposes the APIs, and this cluster info is something that will connect to the API server, fire the kubectl commands, and get the required health metrics. And the second one, which is the Kubernetes monitoring within this deployment file, is an optional container image. Say for suppose if the requirement is to monitor the Kubernetes environment from a robot which is installed outside the Kubernetes cluster. In that case, we really don't require a robot running as a container in any of the Kubernetes worker nodes or in the master node itself. But because we are dealing with the Kubernetes cluster and everything is running in containers and wrapped up with pods, right? We are will also be providing an option to consider UIM robot as one of the container image itself, right? So when we deploy this deployment file, there will be two containers that will be created. One is the cluster info, second one is the Kubernetes monitoring. All right. So, and again, from a deployment perspective, it's up to the Kubernetes deployment that where these pods will be running in. It's purely based on the deployment, but we also provide certain options in the deployment file that let you to run these two containers, cluster info and the UIM robot, on any of the specific node if that is the requirement. So coming to the landscape of what we monitor as part of the UIM capability. So the first one is the master node and all of its key entities. and all the worker nodes and the associated components, including the pods. So that's from a physical entities perspective. And from a logical entities perspective, we monitor the namespace, we monitor the deployment, stateful sets, replica sets, and then the services, right? So this is a very high level overview of what will be available in the first release of the Kubernetes monitoring solution from UIM. I'll start with the deployment file. As I said, if at all we have to set up, say, Redis onto a Kubernetes cluster, we need a deployment file like YAML, right? Or if at all we want to set up Nginx server, a similar kind of a deployment file is required. Exactly in the same direction, there will be a deployment file that will be available from UIM to deploy two container images. The first container image, as I mentioned earlier, is related to the cluster info. So this is the one which is responsible for providing the required APIs and which is wrapped up with certain kubectl commands to capture the health metrics. And then this, and obviously because there will be two parts within this YAML file. One is the deployment, which is actually responsible to run the required number of pods all the times on the nodes, right? As you can see, the replica set is created as one. So there will be one instance that will always be running in the Kubernetes cluster with the cluster info image with the specified version, right? And because deployment only cares about running the pod with the desired number, what is mentioned in the replica set, how do we make it accessible? And that will be driven through this service, right? So we'll be setting up the port through which this container will be accessible to. So what section 1 is about the deployment configuration and section 2 is about the service configuration. And as I said, the second container image is the robot itself. Again, this contains two parts, deployment and service. This will be optional if the robot is outside the Kubernetes cluster. But if at all we want to run the UIM robot as a container image, just like any other containers, then in that case, this configuration is required. Again, this is a robot with configured as with replica as one, and it is exposed through a certain ports for robot connection, right? Few things over here. As you can see, there are few attributes that we are also configuring in this deployment file to which hub this robot has to report to. So basically the hub IP and the hub name along with the UIM domain will also be part of this cluster info.yaml file. So this is something that we will be changing as a user when we deploy this deployment file onto the Kubernetes cluster. So this is part one, which will be available as part of the release. And then we are actually monitoring this entire Kubernetes cluster through the UIM RESTmon probe. So there will be an associated schema, that is Kubernetes schema.json file, just like any other RESTmon schema. And all that it does is it connects to the first container, which will be a pod that will be running in the Kubernetes cluster after we deploy the cluster info.yaml. And again, as you can see over here, whatever the service configuration that we entered in the cluster info, the same details are present in the schema file with the port details and the associated hostname, so that the RESTmon probe will connect to the cluster info container and then capture the health metrics. Now, let me quickly get into a Kubernetes lab environment. So this is a Kubernetes cluster with a 6 node. The first node is the one where the control plane and its components are running, and I have labeled it as master. And the remaining nodes are the worker nodes. So the last one is in the not ready state, and the first 5 nodes, including the master node, are running perfectly fine on this environment. And once the YAML file, the cluster info YAML file, which I have just presented, is present on the Linux box, the master node. So all that we have to run is kubectl space create, and then go to the folder where the clusterinfo.yaml file has been imported. And just run this. So after we execute this, because I have already executed, that's why it is throwing this error. But both the containers will be coming into the running state. Okay, so let me quickly show you the current running pods in this environment. As you can see over here in this Kubernetes cluster, there are a couple of pods which are running. Those are the Nginx related Nginx server instances. And then you can see another two pods, the cluster info, which is the one which is exposing the APIs for consumption from the RESTmon probe. And the second one is the monitoring robot itself, which is wrapped up as a container and running as a pod on one of the nodes. And then there are set of pods which we get as part of the network setup. So in this environment, Calico has been used for the network setup for pod-to-pod communications and the overall network communication setup in the Kubernetes. And then there are few other important pods like the API server, the scheduler, and the kube proxy instances, right? And then there are also few pods that are related to the Redis, which are deployed on different nodes, right? So this is the environment, as lab environment that has been created. Now let's see how UIM is going to monitor this. So as you can see over here, there is a Kubernetes pod that is running, which is under the namespace of DX UIM, and this will be attached to the hub, which is configured in the clusterinfo.yaml file. So I have entered the UIM domain, the hub and the hub IP, right? And the port. So now you can see over here, uh, the port is 30,000 and then it is connected to the hub and the domain, which is configured in the clusterinfo.yaml file. So there are two clusters I'm monitoring from this environment. So that's why you're seeing two Kubernetes monitoring robots, right? And yeah, so this is the cluster IP, and this is where the robot is deployed, right? So this is something that will automatically happen once you run the YAML file, the clusterinfo.yaml file. So nothing additional that is required. So once you get this robot instantiated, you'll be seeing three probes, the controller, HTTP, and spooler. And then once the MCS profile related to Kubernetes is applied on this robot, then automatically the RESTmon probe will be deployed onto this node, onto this robot. Okay, so this is the Kubernetes schema.json file. So from a schema upload perspective, there is no change with respect to the other RESTmon schemas. All that we have to do is get into the settings tab of the operator console, get into the RESTmon integration, and then you can browse the RESTmon schema and upload it. Once the RESTmon schema is uploaded, then you can actually go ahead and select the inventory, that is your robot. So in this case, this is a robot, and get into the mon config service and then set up the Kubernetes cluster. As you can see over here, there are child profiles associated to this Kubernetes monitoring. So all this will be available just after deploying the RESTmon schema related to the Kubernetes. So there are a couple of sub profiles related to cluster. So the way the profiles will be available is if the number of metrics goes beyond 20, right, automatically it will get into the second group. So because cluster has more than 20, by default it will come to group 2, and this can be changed. And similarly, there are get into this quickly. So as you can see, so these are the different metrics that are available at a cluster level, right? And similarly, we can create the profiles for containers, deployments, namespaces, nodes, pods, replica sets. So the implementation with respect to the daemon sets and the services. So those are something in progress, but eventually even those will be rolled out as part of the initial launch of Kubernetes monitoring, right? So we can select the required monitors from each of these profiles and enable the monitoring through the MCS. And once the profiles have been created, what we'll see is a list of inventory that will be discovered by the Kubernetes instance of the REST probe, where we'll be seeing different kinds of device types, including the nodes, the pods, the cluster itself, and then any container which is associated with an IP, right? Uh, so far so good. So we have discovered different kinds of devices. uh, what next, right? So once all the devices are discovered, how do we group those devices, right? Because there will be multiple number of pods, and as we have seen, some of the pods are lying in Redis namespace, some of them are in Nginx namespace, some of them are in default, right? So how can we effectively group the pods and the nodes based on better handling with respect to the monitoring profiles, setting up the thresholds accordingly? Because sometimes the requirement could be like the pods that are running, or the nodes that are running in one cluster may require certain kind of quas and thresholds, and probes that are running in, or pods that are running in different namespaces may have different sets of monitors and the thresholds, right? So how can we actually group these pods, nodes, and other entities that we just discussed, right? So what we have done as part of the initial implementation is, for each entity that we discover related to Kubernetes, we are ensuring that the metadata related to that entity, let's say for a given pod, is properly captured. Uh, I'll quickly show you through SLM. Because it's in the development phase, I'll try to run through few SQL queries. Uh, Give me a minute. So basically, in this use case, what I'm trying to present here is, for a device which is identified as a pod, what are the attributes that we are collecting? And similarly for a node, right? This is just from a use case perspective. As you can see, for a given pod, we are collecting the metadata, like to which namespace the pod belongs to, right? What is the containerization technology? Because tomorrow, once we expand this to OpenShift, right? Maybe we would like to categorize the pods between Kubernetes and OpenShift, right? So this will be one of the key attribute to differentiate. And similarly, what is the node name under which this pod is running, right? And obviously the primary roles and which cluster this belongs to. This will be one of the key attribute, for the reason that as you can see in this environment, there are two clusters that are running, right? So if at all I have to group the pods based on the cluster itself, right? So then this is one of the key property that we need to consider. And similarly, if we see for the nodes, you can see over here again the containerization technology, the role which is the node, and then obviously the cluster name where the node is running or deployed. And more important thing is, what is the node type that is associated for this node? As you can see in my environment, there are certain nodes which are running as workers and certain nodes which are running, and there is a node which is running as a control plan slash master, right? So in that case, if at all I want to group the nodes based on worker node or a master node, then this attribute would definitely help, right? So all these attributes will be available in the computer system attributes table. Just like any other technology like VMware, AWS, and Azure, we are also ensuring that the right set of attributes for the Kubernetes entities are also being captured. Now, once these attributes are captured, it's very easy for us to group it, right? So I'll show you a few examples. For example, these are the namespaces that we have just seen, right? Let's say there is, DX UIM, right? So if at all we want to group all the containers that are running under the DX UIM namespace or Nginx namespace, all that we have to do is when we create the group, ensure that the containerization technology is Kubernetes, which I have just shown in the system attributes table. And the role is pod because I'm grouping all the pods which are related to Nginx in this Nginx group. And then the pod namespace is Nginx, right? So with these three attributes, we'll be able to group all the pods which are running with under the namespace of ingress-nginx. Similar way for other namespaces as well, we can create these groups. Now the question comes that what if there are, say, more than 50 namespaces? How can we actually automate this grouping of all the pods running in namespaces, right? So for that, the solution is, I'll just go back to Silem. As you can see over here that, so we have a table called CM group automatic, right? So this actually allows us to automatically group uh, or to configure automatic groups. So here, as you can see, the pod namespace, which is one of the attribute in the computer system attribute table, has been considered as the field to automatically create the groups based on the namespace value. So what it will eventually turn out to be is, you can see there is a Kubernetes namespace, which is an automatic group that has been created. And you can see all the list of namespaces as group names, right? And then all the pods which are connected to this namespace or which are part of this namespace will automatically come into this group, right? Uh, so, so if a new namespace is created and if a new pod is attached to that namespace, in the next polling cycle of the probe, the namespace will automatically come in to this parent group along with the attached pods. Okay. Similar way, we can also create multiple automatic groups like Kubernetes nodes. So this is a typical example like, okay, so if I have multiple pods running in a node, grouping the pods based on the node name itself is one more option, right? But definitely grouping based on namespace is one of the typical use case where we generally use for setting the monitoring configuration at a group level. All right. So that's about the grouping of the Kubernetes entities. Quickly moving on. So we collected the inventory, we have grouped it, what we are actually monitoring now on these entities, right? So for that, let me go back to SLM again. As you can see over here, these are the different cause metrics that will be available once the profile is created based on the MCS configuration, right? You can see different set of cause related to pod, the containers and the namespace. Just to show you a few samples. So these are different set of quas monitors that are available, which are connected to the namespace entities. And similar way, we can get it for pod nodes, the cluster itself, right? So we can actually verify what all are the different cause objects that are enabled and are those meeting our needs. If not, we have to go back to the MCS profile and enable to meet the needs of Kubernetes monitoring. right? And then we can actually see how many number of rows are being selected, are being so using the show statistics. So this is a typical SLM use case, right? Uh, yeah, so as you can see over here, these are the raw data elements that are collected for this namespace metric. And then, yeah, so it's all about leveraging our performance report designer, get the metrics out. I'll just share a sample. Let's say I'm interested in total running pods. Maybe I'll go with radius. Yeah, it's a typical PRD use case, and you'll be able to see whatever the cause objects that I have just shown in the SLM. Everything can be selected, and then get into the performance reports, and we can create the dashboarding and reporting using these trend reports, right? And then, if at all we want to see a total summary of the deployment, what we are monitoring, right? Definitely, dashboard designer is one option to create and give a complete picture of what is being monitored in a single view. So there'll be one out of the box dashboard that we are planning to make it available for our customers, which can definitely be customized on top of that. As you can see over here, that this is a sample dashboard that has been created based on the data, based on the devices that we discover and the data that we monitor. So this is about the alarms around the Kubernetes monitoring. And this is what I said earlier, the key components of the control plane, the Kube API, Kube scheduler, and the control manager, and the health of all these entities. And you can see there are 9 nodes that are running and 43 pods. So this is across the clusters. And then there are 35 namespaces and 89 containers. Currently, all these containers are driven through the and managed by the Docker container interface. And this talks about, okay, so for the cluster, what is the CPU memory and disk free percentage. So this will give you rough picture around the overall health of the Kubernetes cluster deployment and the master node. If you slightly come below, you can see you can create a list view, something like top 10 pods. Uh, Currently, I just limit the row to 10, but it can be based on the average response time or memory usage or any other metric through which you can derive your top 10 pods. And if you slightly come below, you can actually see the node performance for a given node and you will be able to see all the list of nodes over here that are actively being monitored. You can select the desired time frame and then see the health of the nodes, right? So this is one dashboard which is still work in progress, but as part of our release, we are also planning to give this as an out of the box dashboard. And definitely this can be further customized based on the needs.